Okay, since you guys are the first class this week, you guys will be recorded.
Yes.
Okay, number 2, B and C. Say what? Not Q and S, not R implies P, not R or not Q. Okay, what's the first thing you want to do on this first one? Distribute. Remember De Morgan's law? So if you distribute the negation sign, you're going to get Q or not S. Or have we forgotten that? Distribute the negation sign, but then you got to change the and to or. And then when you have an or statement, can you replace that with a conditional? You bet your sweet baby you can. Negate the first, leave the second one alone. And then same thing with this. You have an or statement, replace it with a conditional. Negate the first, leave the second one alone. And then now you want to join them all up. You have 3 conditional statements. You can use the law of syllogism, right, for this. So which one do I start with? How do I know which one to start with? Why? Why do you say S? Well, either you can start with the S or the P. Why? Yeah, because there's only one of each, right? And they got 2 of the others. So which one do you want to do, the S or the P? Okay, so if you contrapositize this one, you get S implies Q, right? If you contrapositize this one, you get Q implies not R. And then if you leave that one alone, you get R implies P, right? They're all hooked up, right? Here, so here, S implies Q, Q implies not R implies P, therefore, S implies P. Of course, if you did the other way, your answer would have been not P implies not S, which would be the contrapositive one, right? Which is the same thing. Now, do you guys understand? You look for the one that only has 1? Because if you're going to use the law of syllogism, look, this has to match with that, this got to match with that, so you only have this and this. Okay. And then C, go to your room. You're grounded. Okay, the disjunction of C and A, doesn't that mean C or A? Disjunction is or, right? I showed you guys how to remember that, right? I didn't show this class. How come some people saying yes, some people saying no? Morris, you're grounded. Did I not show you this? Disjunction means or, but conjunction means and. Oh, now I get it.
You just put the or.
That's being silly, though. Okay, you can choose any way you want to remember it. This is the way I remember it. A is a sufficient condition for not D. Now, does that mean A implies not D, or does that mean not D implies A?
Yes.
Or does it matter? Which one?
Not A.
No, not A.
I mean, A implies not D.
Yes. A implies not D. And then D is a necessary condition for B. What does that mean? B implies D. How do I remember sufficient and necessary, Mr. Park? Well, this is the way we remember it in the method. Sufficient condition. Necessary condition. See how it's sufficient? See how the F's point that way? So it's like this implies that. What's so funny? But in necessary, see how the Y points down? So it's this implies this. This one is not fun. Okay, this one was stupid, I just made it up. But this one actually works. This one actually works. See how the F's point down and the Y points this way? Because before I used to tell them this. See how the S is pointing down? This one, the S is pointing down. Okay, so if you don't symbolize it correctly, then it's pretty much all over but the crime. So the first thing you want to do is replace this with the conditional. How do you do that? Negate the first, leave the second one alone. And then again, you have three conditional statements, so you're going to put them together with the law of syllogism. So which one do I start with? This is like the last problem. Either B or C, because I only got one of it. So which one you want to do? Okay, B. So B implies D, so then I need D implies something. How can I get that? From the contrapositive of this. D implies not A. Then I need not A implies something. Where can I get that? The contrapositive of this. So not A implies C. So if B implies D, D implies not A implies C, therefore D implies C. Or if you went the other way around, then you would have had not C implies not B, but that's the same thing, right? Contrapositive. Okay, and then 4, 5, and 7. This is period 6, right? The smart class. Okay, the moon is full. What do you want to use for that? M or F? Okay, the moon is full if and only if it is cold. If the goblins are out, then it is Halloween. It is cold. If it is Halloween, then the moon is not full. See, we should have used F for moon, because then that looks like not moon. You want to change it?
Yes.
Too late.
No.
Put it already.
That's right.
Okay, let me ask you this before we even start. Do you think the conclusion is going to be just a single statement or a conditional statement?
Single statement.
Why do you say that?
Because you see.
Yeah, because of this, right? When you have this, you're going to use modus ponens, right? What's that? Gorilla implies banana. Gorilla, therefore banana. See, when you have just a single statement there, then when you use modus ponens, you're just going to have a single statement. But if it's all conditional statements, then the conclusion is just going to be a conditional statement. Are you guys following? It's following the pattern. Okay, now, you probably are confused because I don't know what to do with this one, Mr. Park. Well, remember, biconditional, look at the arrow, goes both directions, so you can use it whichever direction you want. Because this means M implies C, and it also means C implies N. So which way do you think we're going to use it in this problem? We're going to use it as what?
C implies N.
Okay, why do you think we're going to use it as C implies N?
Start with C.
Because they're C, so you can use modus ponens. Okay, let's put this the right way. This is, okay, C implies M. Okay, then I need M implies something. Where can I get that?
The bottom.
Contrapositive of this, so not H. Then I need not H implies something. Where can I get that? The contrapositive of this. So based on these three statements, what can I conclude using the law of syllogism? C implies not G. But then C, therefore, not G. Right? That's modus ponens. And so what's the conclusion? The goblins are not out. See how easy this is? You just got to know modus ponens and law of syllogism, and you can figure it all out. Okay, 4, 5. Okay, so let's do it over here. 5. Okay, either logic is difficult. What do you want to use for that?
L. D.
Either logic is difficult or not many students like it.
L.
What?
Not L.
Not many students. Not
L.
student. Whatever. Just do this whatever you want. If math is easy, then logic is not difficult.
Not D.
I'm not listening to you already. Many students like logic.
S.
What conclusion? So, again, what do you think is going to be the conclusion? Single statement or a conditional?
Single.
Okay, so here we go. We got S. So what you want is S implies something. How can I get that? Well, from this. How you have an OR statement, replace it with a conditional. Negate the first, leave the second one alone, and then contrapositivize it. S implies D. But then I need D implies something, so you contrapositivize this, so D implies not M. So if S implies D and D implies not M, then S implies not M, but S, therefore,
Not M.
not M. Now what does that mean?
Math is not
Math
easy.
is not.
Okay. That's dumb because math is easy. Okay, number 6 you got, but number 7. Okay, didn't I tell you guys how to do number 7 yesterday? On a Friday?
Yeah.
Fine.
Okay, look, number 7. You got Michael, Jermaine, Tito, and Marlon. Well, only one of them is a drummer, and only exactly one of these statements is true. So, okay, so what if this one is true and these are false? Did you try that?
Yeah.
Did you get a contradiction?
Yeah.
Yeah, so then you go to the next one. And you just keep on going until you hit it. It's, you know what I mean? Do you guys know what I mean by a contradiction? Okay, what if the first statement is true? Jermaine is the drummer. Okay, that's true. That means Jermaine is the drummer, right? Okay, but the next statement is false. Marlon is the drummer is false, so that means Marlon is not the drummer. Okay, I am not the drummer is false, but then so that means I am the drummer. So Tito is the drummer, but then from the first one, Jermaine is the drummer, and you only can have one drummer, therefore that's not it. You know what I'm talking about? So then you go to the next case. What if this one was true and the other 3 were false? Did that one work? No, then you go to the next one. This one is true and these are false. Did that one work? No. So then, what if this one is true and these are false? Did that one work? Yeah, see how I made the last one? Yeah. Unless you went backwards. So that's the one, and then you've got the answer on the bottom, right? So that's how you do logic puzzles. Right there. Okay, so today we only have to learn one more thing. We learned, so tonight's homework, this is, like I said, this is the exact test I gave like 15 years ago. Okay, so what you're going to do is you're going to do it, when you come to class, you're going to write your answers on the board. So how many problems are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, the 15 problems. Okay, where do I see 15 people? Right here. 5, 10, 15. So when you walk in the room, I'm going to have the numbers on the board. You just fill in one of them. And then I will go around grading them. I'm going to grade it exactly like I grade a test, and so you can see exactly what's going to happen on Wednesday. Question?
I only have 7 columns. Oh, ABC. Oh, okay.
Wait, so like on the board you show like our work and everything?
Yeah, that's usually how it works. You don't just write down the answer. The answers only work like 1 point. You gotta show your work. Okay, so, okay, first of all, argument. Okay, let's look at modus ponens. What's modus ponens? P implies Q, P, therefore Q. Is this a valid argument?
Yes.
Yes, I proved it to you last week, right? How did I do that?
You went through the hand.
No. Okay, okay, look in your notes. Under arguments, there are 3 ways to show that an argument is invalid or valid. Okay, the first one was make a truth table, right? Whenever, so you look for the lines. Whenever these 2 are true, this one has to be true, right? And if it is, it's a valid argument. Okay, what's number 2? Did we go over that one last week? I don't think so. We ran out of time in one class, so we had to do it in a lot of classes. So, what does it say? Method number 2. If the conjunction of the premises implies the conclusion is a tautology, then this is a valid argument. What did you just say? If the conjunction of the premises, okay, these are the 2 premises. What does conjunction mean? And. So if I add these 2 together, implies the conclusion is a tautology. What's a tautology again? That's when the truth table comes out all true. Then this argument will be valid. So here's the first premise. Woo! Here's the second premise. Oh, what am I even doing? I'm doing the first way. the conjunction of the premises. Here's the first premise, here's the second premise, and full implies the conclusion. If this is a tautology, then this is a valid argument. But we already know it's a tautology. How do I know? Yeah, you already did this on your homework. Remember the homework on Logic 2 where it came out true every time? That's exactly the same problem. So you already did this already. So this is true, so therefore it's a valid argument. Okay, but you already did this before, so let's do another one. How about this? P implies Q. Q implies R. Therefore, P implies R. What is this?
Syllogism.
Law of syllogism. Okay, so what if on the test I ask you to prove that this is a valid argument by showing that the conjunction of the premises implies the conclusion is a tautology? Just go to the next problem. Just take the -8.
No.
Boy, if you take the -8, you're below the class average already, right? The class average would be 95. So P implies Q, the conjunction of the premises. So here's the first premise, here's the second premise. The conjunction implies the conclusion. This has to be a tautology in order for it to be a valid argument. You guys understand how to set it up?
But then would you do like a table or something?
Yeah, you make a truth table. Because once a tautology, it's a statement that comes out true every single time. So how do you know if it's going to be true every time? You got to make a truth table.
So you have like P, Q, and R, and then you do all these.
Exactly. Okay, now this is, I don't know how many days we've been studying logic already. Can we see it in our brain, or do I have to make the training wheels? You sure?
Yeah.
Okay, let's see. Let's see it, love. First column, for this one right here, fill it in.
True, false, true,
True, true, false, false. True, 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 true. Is he correct? Okay, let's make the training wheels. See, that's why I erased it, because I knew we were going to make the training wheels.
Oh, Mr. Park, what?
You like being clear that? Is that it? True, true, false. And then true, false, true, false, true, false, true. Okay, so is he right on the first one?
Yeah.
P implies Q?
Yeah.
You are correct. Okay, what about this one? Q implies R. Who's going to think this one? Ching! Okay, that's right. True, false, true, 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 false, true, true. Now we have to add them together. Oh,
True, false, false, true, false,
what?
No, wait, what?
What?
True, true.
True, true. Okay, so this column here represents this. Okay, P implies R, so this one implies that one. Cito.
True, true, false.
So whenever I do that, just go with the other one.
True, false. True, 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 true.
Okay, correct. Okay, so this column represents this. Now we gotta go, this implies that. Morris, redeem yourself.
True, true, true.
See, look, see, he's playing the game. See, he's pretending like he's thinking. No, this is how you play the game. He's pretending like he's thinking, but we already know this is a valid argument, therefore it has to be a tautology. You know what I'm talking about? It has to come out on truths. That's how you appear smart. True. So you double box with did you guys do that today? Double box with asterisk?
Yeah.
Okay. So yes, it came out to a tautology, therefore this is a valid argument, yes.
Do you have to circle the other ones?
No. Okay, so that's the second way, and there's a third way. Okay, read it. What does it say?
Indirect proof.
Indirect proof. Okay, but when you do an indirect proof, basically we just use it to prove validity. You cannot use it to prove invalidity, as you will see. Okay, let's do modus ponens again. P implies Q, P, therefore Q. Anyway, we already know it's valid already. We already did the first two ways. I'm just going to show you the third way. Now, what the heck is an indirect proof? This is a very famous way to prove things in mathematics, okay? Now remember, what is a valid argument? If this is true and this is true, this will be true. Okay, so invalid argument, I'm just going to tell you the strategy first. The first step is we're going to suppose that this is false. Okay, but these are true now. Anytime you have premises, you assume these things to be true. So we're going to suppose, what if the conclusion is false? Just suppose that. So we're going to take that and we're going to go back into here until you get a contradiction. And you will get a contradiction. And if you get a contradiction, that means your supposition that this was false was wrong. It was actually true, so therefore it's a valid argument. You do it indirectly. Okay, so let me show you. First step in any indirect proof, suppose whatever your conclusion is false. Which of course means what? What does that mean if Q is false? No, we'll go with that. We'll just say Q is false. Okay, now, we're assuming these two statements to be true now. Okay, so what you do is you take this back into here until you get a contradiction. Okay, now, if we know Q is a false statement, but this conditional statement is true, what can you say about P? False. P has to be false, right? So P must be false in premise number 1. Does anybody see a contradiction? This one's easy. Yeah, this is true. See? How can you have a statement that's both true and false? That's a contradiction, right? So, contradiction. And this is the happy part of the proof, because you want to find a contradiction. P cannot be both true and false. Therefore, the argument is valid. You guys understand what I did? In order for an argument to be valid, if these two are true, that has to be true also. But we're going to suppose this is actually false, which we did. But then when we take it back in here, we get a contradiction, which means our supposition was not correct. This was not false, it was actually true, therefore the argument is valid. Oh, so this is the part we're going to write a paragraph in. Yes! This is writing a paragraph. Indirect proof is a paragraph. So this is what I'm looking for. Question. Okay, let's just do one more and we're done. One more example. Okay, let's look at law of syllogism again. P implies Q. Q implies R. Therefore, P implies R. Now, we already know this is valid, right? Prove that this is a valid argument by doing an indirect proof. So what's the first sentence in any indirect proof? Suppose this is false. Remember, if this is true and this is true, this must be true also. So we're going to suppose that this statement, P implies R, is false. Which means what? Thus, when is the only time a conditional statement is false? When the first one is true and the second one is false. Thus, P is true and R is false. Does everybody understand that? The only time a conditional statement is false is when the first one is true and the second one is false. That's why you gotta know all these things, otherwise you can't do it. Okay, now, take these things back into the premises until you get a contradiction. Okay, which one you wanna use?
1.
Okay, well, we know P is true, so if P is true and this conditional statement is true, what can you say about Q?
True.
Yeah, so Q must be true in premise number 1. I'll just put P1, help you guys. P1. Okay, now, if this statement is true, and we know Q is true, okay, true. If you have a conditional statement that's true, and the first one is true, what can you say about the second part?
True.
No, we already used thus and so. Hence, R is true in premise number 2. Does anybody see a contradiction?
Yeah.
Right here, we said R is false, but then now we said R is true. Why am I writing on true? Just put T. Not consistent, -1. So here's a contradiction. So contradiction, oh, R cannot be both true and false, therefore the argument is valid. Woo! There you go. Yeah.
So if you don't find a contradiction, you just don't write any of that.
Okay, so here we go. What happens, Mr. Park, what if I do an indirect proof and I don't find a contradiction? What does that mean? No. I just told you. We only use indirect proof to prove validity. And the reason why is because just because you cannot find a contradiction, that doesn't mean one doesn't exist, right? You just didn't find it. Right? So just because you cannot find a contradiction, that doesn't mean this is invalid. It just means you didn't find a contradiction. You understand what I'm talking about? Just because you didn't find one, that doesn't mean one doesn't exist. Maybe you're just dumb, that's why. So that's why we only use indirect proof to prove validity, not invalidity. Anyway, on the test, you're thinking, Mr. Park, I don't want to write all this. And you'll be happy to know that on the test, when you get this problem, I'm going to write the whole proof for you. All you have to do is fill in the truths and falses like this. No, right there. No, I'm serious. That's how I do it every year. So it's so easy. 50-50 chance on every line. It's either true or false. Unless I do things like this. Blank. And then contradict blank. Therefore, the argue blank. Blank. You want me to do that?
No.
Okay. You guys just fill in the true and falses. It's so easy, right? Okay, now you know everything there is to know about logic. Well, the basics of logic. Because when you go to college, you can actually take a whole course in logic. In fact, you can get a PhD in logic if you want. You can be a logician. Just like Augustus de Morgan. In fact, okay, what if you're in a Turkish prison? The only way you're going to get out is you got to name 3 logicians. Could you do it? I just told you one. Augustus de Morgan. Okay, if you took computer programming and engineering, remember I told you how those networks relate to logic? Who is the guy responsible for that? What? Did you guys ever hear of Boolean algebra?
No.
Some people did. Why? For computer programming and electronics, that's why, right? And who's responsible for this? George Boole. Not Boolean, George Boole. Like we call it Euclidean geometry. What's the guy's name? Euclidean. George Boole. Okay, here's another one. You got it? He wrote Alice Through the Looking Glass. You ever heard of Alice in Wonderland? Based on Alice Through the Looking Glass, written by Lewis Carroll.
How do you know that?
That's common knowledge. Anyway, Lewis Carroll wasn't just an author now, he was actually a logician. That's why in Alice Through the Looking Glass, isn't there like a lot of logic things? Did anybody, who read the book? Do you know that Lewis Carroll is just a pen name for a real person? Yeah, what's the real name of that guy? Okay, I'll give somebody food if they know. What was the real name of Lewis Carroll? Charles. No, yeah, you're right. No, you're not right. You actually thought you were right. Charles Dodgson. Why are you laughing? Why don't you go impress your English teacher with that? Actually, there are more. Those are probably the 3 most famous ones. Okay, that's it. The bell's going to ring in 4 minutes. So remember, the 15 people, pick one problem and you just go there tomorrow. Right over there. Oh, wait a minute. How are we going to get this on camera? Tomorrow we don't need it on camera. No, we do. So whatever's here, that's it. Maybe we got to pan the camera. I don't know. We'll find out. We'll figure it out tomorrow. Not one person in this class read Alice Through the Looking Glass. Unbelievable. You might have. Then no sense to even ask, did you guys actually read Flatland? Never mind. Oh, okay.